2024 was a year full of astronomical events in Vermont.
Hello, my name is Terry Zittrich. I'm currently the president of the Vermont Astronomical Society. I've been on and off with VAS since the 1980s. So I got involved with VAS initially because of a person I worked with. I worked at IBM, and a person by the name of Russell Camella, who our observatory is named after, told me about the VAS, because I told him I had a telescope at the time. I bought a Schmidt Cassegrain 8-inch telescope, a Meade, and I had bought it with money I had gotten after developing my first patent. So IBM gave us financial incentives to invent things, to patent things. So I'm an electrical engineer. It was at IBM for many. When we got our first patents, they gave us some money, and I went out and bought a telescope. And Russell found out. I happened to be talking to Russell. He worked with us at IBM, and he invited me to the VAS. And at that point in time, I went to some VAS meetings. This was in sometime in the 80s or early 90s, and then I had a family and career and all that got busy. So while I still did astronomy, it was more of a personal endeavor. I did it at home, and then as I was approaching retirement. In the teens, middle of maybe 2014 or so, I decided, I still enjoyed astronomy. In fact, I was doing a little bit more. I was doing a little bit of planetary imaging, and I thought, well, I'll look at the VAS again, and I'm going to have more time. I'm going to retire, and I joined the VAS. And I wanted to be active. I really enjoy the outreach aspects of VAS. That is going into schools or to libraries or to communities, and we do events. We show people the sky. We bring our telescopes. We show people, nebula and planets and double stars and things that we can see. And people get really excited when they see things like Saturn for the first time. It's just amazing. It's when people see Saturn. I'm still learning. There's
several members who do photographic imaging, and the stuff they do now, even in our club, is the stuff you would have seen in magazines and books 20 years ago or so. It advanced so much recently, and they do a deep sky image. They could take several hundred or even a few thousand images of the same thing over a period of time, sometimes hours, and then use software to merge the best ones together. And then that produces, with a little enhancement like with Photoshop or something, to bring out some more details. They get some incredible images.
Tons to learn in astronomy. So I enjoy taking pictures. And I enjoy visual as well. So I'm odd. A lot of people either do imaging or do visual, and many of them don't cross over. They just do one or the other. I like to do both. So I do. I like to do everything. I like to learn everything. So here I'm in the settings. So I can, when I'm in the house, I control the observatory, so I can open the roof. I don't know if you can. So we can go to the observatory. So what you have. So this is the imaging scope I have connected right now. So it's on a equatorial mount, a German equatorial mount. It's all anchored in a giant hunk of concrete here that goes down 4.5 feet. So what you have in the observatory is, you have the telescope, you have a automatic focusing control, a guide camera, the main camera. This is the filter wheel, so this spins inside, and there's 7 filters, different filters. So if I come over here, power supplies. This is the computer. The tinfoil covers the lights for all these things because any stray light is bad when you're imaging. I have an internet connected power source, so I can control the power via the internet. So I've got a small computer, so that runs everything, and I do it remotely. I do it from a laptop, so in the house. So this is just a manual roof control. So I can open and close the roof from here. This is the roof controller. So the roof controller makes sure the telescope is parked, because if the telescope is up, so if I connect the telescope to my computer here, if the telescope was up looking at the sky, the roof would hit the telescope. So there's a sensor that tells me the telescope is parked, and it's okay to close the roof. So it won't close the roof with unless the telescope is parked. I'm doing solar imaging during the day. I'm typically holding my computer. I've got the telescope taking images, and I'm doing things interactively, but usually at night I don't spend a lot of time unless I'm doing visual. So I can take the camera off and I can do visual observing. I can be inside when I'm doing imaging, but if I'm doing visual, I have to be out here. So I would have, like, I would put maps and stuff on the tables, and I would look through an eyepiece.
Cool.
So what's called a motorized light panel, so it opens and closes when I'm doing the imaging at night. The telescope can go up. So it would follow, an object across in a German equatorial mount. This axis points towards the North Pole. It's very close to the North Star, but not exactly, of course. But so it points. It has to be aligned precisely, and then it will track the sky in this direction. This axis is the declination axis. So this one that goes north and south. This is declination. This helps me find a particular item, because everything in the sky is at a particular right ascension and declination. So that's how it will track very precisely. This little camera here is the guide camera. So this is the one that tracks the star. So I'll pick a star, and it sees light through a very small pick-off mirror. It's just a diagonal mirror, so I can get a very small part of the light from the main view with a couple of stars in it, and I can track a star very precisely, whereas this is the main camera. This is a 16 megapixel cooled astronomical camera. The USB goes to the USB hub here, and that hub is connected, it goes through the mount, comes out of the mount here, and goes to the computer. So, the computer's running the mount right now. That's what's running everything, and I'm just interfacing with the computer through a remote access to the computer.
Right.
I'm tracking, it would, I'm just slewing right now, but
Sure,
when it's
yeah.
when it's tracking, it's moving almost imperceptibly slow. In fact, it's tracking now, you can't really see it move.
Oh yeah, totally.
So it is tracking. Oh yeah, I use a star map, and so all of the control software for both the mount and the imaging software uses coordinate system, same coordinate system. So you have to know exactly where you are on the face of the Earth, right? In latitude and longitude, and that's how you set up all the software that runs the mount and the planetary programs.
Did you just have to type in your coordinates?
Well,
You know what I mean?
this is a little more sophisticated than just this, so in this case, I align the mount very precisely to the north polar axis, and I do that with some software that does this thing called plate solving. And
It does what?
This thing called plate solving. It compares the sky to a known set of stars at known coordinates, and so it can it can very accurately, within a couple of pixels of my camera resolution, align the telescope mount and the telescope to the sky. So I know exactly where it is. And so once it's polar aligned, then it's just a matter of actually just finding one object and centering it. And usually I do that with plate solving, again, very precisely. So I leave the mount on. The mount's actually on all the time. So when I start using it, it will go exactly. When I point to something, it'll be smack dab in the middle of the frame.
Wow.
Very precise. Yeah.
That's awesome.
Yeah. So and when I turn it off once, when I turn the mount off, that information goes away and I'll have to realign it, but I only really have to do one plate solve because
Yeah.
it's already polar aligned. So once I plate solve it on a particular object, it'll be perfectly aligned again until I turn off the mount again. Make the tracking mount. So their company, it's actually an American company, makes the mount and the telescope. So it's Astrophysics is the company. It's in Illinois. I believe they're in Illinois, and Telescope Engineering Company is in Colorado. So.
And what's that?
That's that's an old pier. So this is the pier here. So that's one that actually rises and lowers.
Oh, wow.
So, but it wasn't precise enough for me, so I needed something more stable, so that's why I got this solid steel one.
Damn.
So.
I gotta get me one of these. That'll do it?
Yeah. And it close the roof here.
It's being parked.
So when it's parked, my computer tells me it's safe, and then I can do a roof closure.
Wow.
And I made it just high enough so that it's not going to hit me when it moves.
Yeah, I was gonna ask. Wow.
Has the Vermont Astronomical Society ever made any scientific discoveries, like discovered a comet, a nova, like breakthroughs in telescope making, etc.?
Yeah. Gary Nowak, he's a member. I think he's a life member. Been in for a long time. He spent so many years looking for supernovas and comets in the sky. You all have a specific things to look for. And one time, he was out to the site in Heinsberg, the observatory site. And it wasn't a great night for viewing, so he didn't want to spend a lot of time. So he took out his 7x35 binoculars, did a quick scan, and noticed something odd in one of the galaxies where he looks. So that night he co-discovered a nova, a star that flares up.
What year?
It was in the 80s, I think. But he was with 7x35 binoculars. That's knowing the sky real well, knowing what you're looking for, and dedication, because he spent at least 15 years before that time. Yeah, star maps and star charts to look for, yeah. In certain areas he'd look. Another member, Larry Garrett, I think to date has observed over 1,300 asteroids, which are not easy to find, because they're tiny little dots.
New asteroids?
Different asteroids, yep. So that's also knowing the sky well, having detailed charts, and the dedication to get out there and look and spend some time looking for changes in the sky.
Surprised. Well, there was actually two discoveries made. First, 2004 MO1 had been lost for a couple of days. It had not come through for the MPEC, had not been issued, and so I pretty much thought it was lost. But then it came through. I was notified through Spacewatch, which was a Paul Allen sponsored asteroid hunting program. And that came through, and all of a sudden, I was an asteroid discoverer. And what I discovered right after that Cloud 9 was real, because I couldn't feel my feet for 2 days. I really was so excited that I I felt after a couple days coming down, all of a sudden I'm like, wait a minute, the gravity is pulling me down. It's just a big thing, you know. It's just a big. I think that was 2004. When did I started looking? 1974. That was my first one, and 3 months later I found my second one, and that wasn't quite as pronounced then. That was only just very short. I felt it was for me. I don't know how many other people have it, but it was quite a feeling. What they did was the space launch program. It's still archived online, I believe. What you did was you went to bed at night, buy a computer, and then all of a sudden an alarm would come on, and they would say that there's asteroid images to be reviewed. And actually, I helped them develop the music alarm. I said, everybody it was disorganized, and I said, wrote the group, because we had a tight little group of observers of people internationally met. I said, it's like, you need an alarm because people were just logging on, and you never knew when there was going to be images. But then so what they did was they organized it so that they released them in batches with music. And I used to sleep by a computer, and I would get up 3 or 4 times a night hunting them, and then go back to bed and come back and from work and go back to nap and do it about 20 nights a month. And after around, I'm not sure how many images I looked at, 360 something or something like that, the nights. I finally found my first one like that, but it's really, and I hunted them for more than a year. I never found another one after that, but then the program was defunded and all that. It came to an end. But that's what you were doing. You were online reviewing pictures, and with the asteroids would be streaks. And my 2 asteroids were 2004 M01 and 2004 SA. And I got a kick out of it, the names of them too, because I nicknamed them M01 as my own one and SA as second asteroid. And it worked right out.
Remember Bob Horton? I call him a glass wizard because you can grind telescope mirrors by hand. And the accuracy to get a parabola to be the right shape used to be if you got like within a 1/4 wave or 1/8 wave of light, wavelength of light, which is really tiny, then you had a good mirror. And he has done 1/22 of a wave or better. I mean, he's just amazing. He's still doing it. I think he still does it. I've done a little bit, but nothing like these guys. Favorite picture. I took a picture of the moon in Shelburne Observatory in the late 60s, coming over the mountains. Just about a sense. It's a full moon, with a number 2 Brownie box camera.
What's that?
It's the first kind of cameras that used film. You push the button, it goes click, and that's all there is to it. There's a little lens. There's nothing else to it. It's a box.
That rules.
Yeah, I gotta find it and I gotta
Is it
copy
digital?
it. No.
Oh, shoot.
No.
Okay.
Okay, if you want to learn more about astronomy or using a telescope or any of that stuff, come to our meetings. We do the meetings, usually it's the first Monday of each month. Unless it's a holiday, then we'll go to the next week. And we do it in person and by Zoom right now. And that's been working good. And we can help you with either selecting a telescope, supplying a telescope. We have a recycle program where we take scopes donated to the club, refurbish them, and sell them at a really decent price, just to make sure they get a good home. But we can help you with all aspects of it, from very beginning, or using binoculars, or learning how the sky moves, or any of that stuff, all the way up to imaging.
You provide star maps? Or?
We can, if we don't have them, we can tell you where to get them. Yeah. And there's software programs you can get online, put on your laptop, and it's pretty cool. But the thing that you can actually take out you don't need power for, are these planispheres. You can get it, I think you still get them at a bookstore. And it's a printed analog computer. You dial in the date and time, and it shows you what the sky looks like, the constellations, right then. And but we can help with most anything.
And you don't need prior experience?
Don't need prior experience, no. The biggest tie to astronomy is with the publication of how to build your own telescope. And that came from Russell Porter down at Springfield Telescope Makers. That's the group they became. Russell Porter. He worked at Jones and Lamson
Right.
down
Oh,
there.
right,
Yeah. So he's the one who got the group together to make those first bunch of telescopes. There's like 14 people, one woman, and the rest were men. But they did. I think all of them but one made their telescopes, finished their mirrors, and so that uh, became published in Scientific American. And from that, all that stuff, Russell Porter was asked to do some work to build the Hale 200-inch telescope in California because it was need to be developed. And what he did, because he was such a great artist and he can conceive all kinds of the way things are supposed to be, he would draw three-dimensional cutaway views of what pieces and parts of the observatory and telescope should look like out of blueprints. Stuff wasn't even built yet, and he could draw three-dimensional cutaways of what it was supposed to be. So you go to Stellafane, they have some of his sketches down there.
He was from Vermont too.
He was originally from Massachusetts, but he became a Vermonter. He came to Vermont.
Wow, that's sick. I didn't know.
So that beginning of the movement of amateur telescope making in Vermont is our big tie to astronomy.
So this is a Dobsonian, basically horizontal motion and vertical motion. And then there are it's called digital setting circles that allow you to track to a particular object just by pushing it in.
Sick. That's so awesome.
What else I got? I have another toy. I have another toy that I can make available for those who might be so inclined. This is the way to go.
Ooh, oh yeah, go. Come look at the moon, y'all. Yeah.
Are you allowed? No, the moon is mine.
This is Gru. Yeah, look how moon she is. Would you fuck the moon?
Yeah.
Come look at the moon, y'all. It's lit. What do college kids say nowadays? Lit? 6, 7. Am I right, guys?
Guy. We say that sometimes.
I think I deserve the chair for that one.
Is it even legal in Vermont?
Yeah. Actually, we're the state that had the last electric chair in history. Yeah. Where was that? Do you know?
I do not know.
But it was here.
I know we had
No, we were the last electric chair users. I mean,
Yeah.
Have to have 3 cameras. The wart, you can't. Oh, that one on top. That's just kind of a pointing camera. A lot of times they're setting up trees. Yeah. And so it's a situation where I don't get an image from the rear camera, the big one. You know, 10 seconds, 30 seconds, whatever. But the little one's more real time. So they tell me when I'm pointing someplace that's like, don't move.
this is a Schmidt-Cassegrain telescope, so it's a folded light telescope. So the design allows you to have a really compact design with a long focal length. So this is a 2-meter focal length scope. Whereas a regular Newtonian, I mean, you'd have to have or a regular refractor, you'd have to have something that was 2 meters long.
And how does a telescope work?
What's that?
How does a telescope work?
Well, primarily it collects a lot of light. What it does is it collects a lot of light with the aperture. So it creates an aperture, you know, it's like your eye being magnified by the area of the aperture, right? When I say magnified, I don't mean making it smaller. You're gathering more light, right? Because your eye is now 8 inches around in this case. And what it does is the lenses and the mirror, it focuses the light to a small area. And then the eyepiece is like a mini telescope, because the eyepiece then has a certain focal length, just like the telescope. And oh my gosh. We don't need
Edit that out. Edit that out.
And I'll stand behind the telescope. And then the eyepiece then magnifies that cone of light that's coming out of the telescope as well. So you've got two things that affect the magnification of the scope.
Oh yeah.